Good afternoon, students. As you remember the last lecture, we have discussed about circuits and circuit elements, and also we have represented their symbolic representations. Now, in the next topic, we are going to discuss about Ohm's law and experimental verification of Ohm's law. Students, you know about Ohm's law. Actually, there is a relationship between electric current. That electric current we will denote by I, and also potential difference that in the last lecture we have denoted by V. I represents potential electric current and V represents potential difference. Now, in between these two parameters, that is current and potential difference, it was George Simon Ohm, actually German physicist. In 1826 he studied this relationship, that is between current flowing through a conductor and potential difference applied across the two ends of the conductor. Like we have a conductor, simply a wire having two ends, and A and B. I told you in the last lecture that with the two ends we can connect a battery having two terminals, positive and negative terminal. That is combination of cells, combination of two or more cells, that is known as battery. And battery, it means battery, with the help of this battery we are applying a potential difference. That potential difference is denoted by V, and electric current flowing through this conductor, through this wire AB, when a battery is applied across the two ends of the conductor, and that current we have denoted by I. But George Simon Ohm was the scientist. He studied this relationship between this potential difference denoted by V and the current denoted by I, which is flowing through a conductor. According to this relation, this law states that current flowing through a conductor, that current we have denoted by I. Again, I am telling you, current I flowing through a conductor is directly proportional to V. That means according to Ohm's law, I is directly proportional to V. That I have mentioned here. I is directly proportional to V, or we can say V is directly proportional to I. It means as we increase the potential difference, current through the circuit also increases. Or we can say V. We know that this directly proportion is replaced by equal to sign and one constant we are using. So I have used it here equal to sign, and the constant R I have used it here. This constant R is known as constant of proportionality and is known as the resistance of a conductor, and is given by, from this relation, that is V is equal to Ri, we can say R is equal to I को transfer करते हैं V upon I. So we can say this relation gives us R is equal to V divided by I. That is, we can say it is defined as the ratio of two parameters. Again, two parameters, there was a relation between I and V. Those two parameters are now in the ratio. That is the ratio of potential difference applied across the two ends of the conductor with respect to current flowing through a conductor. Current is flowing through a conductor, but potential difference is applied across the two ends of the conductor. Similarly, we can calculate from this relation, we can calculate R, units of R, that means unit of resistance. We know that potential difference in last lecture I told you its unit is volt, and electric current it is measured in ampere. Volt by ampere, that is known as ohm, and the symbol for ohm is this, and this is a Greek letter actually, which is known as omega. So we can say unit of resistance is ohm. Now we can define also 1 ohm resistance. We can say resistance of a conductor. Now what about this resistance? Resistance is actually a property. Resistance is actually a property of a conductor. Which property? By this property, it opposes, the current opposes the flow of electrons. We know that in last lecture I told you electric current I is equal to Q upon T. Q upon T means charge flowing with respect to time. Charge flowing with respect to time. Charge, we can say electrons, we can see in terms of charge, we can say electron is also an electric charge. So flow of electrons with respect to time, that is known as electric current. That means we can say I is equal to E upon T. What is E? E means electric charge and T means with respect to time. How much amount of electric charge flowing through any section of the conductor in a given interval of time, that represents electric current. So we can say now opposition to these electrons, if electrons are flowing through any section of the conductor, opposition offered by the conductor, that conductor, suppose we have a conductor, simply wire AB, electrons are flowing from end A to end B, but this conductor have its own resistance. This conductor has its own resistance which is always opposite to that of direction of electrons, which is always opposite to the flow of electrons. That opposition we have defined here. That opposition is known as the resistance of the conductor, which is denoted by R. And symbolically we are representing this resistance of a conductor by a symbol. That symbol I have drawn here. I told you already in the last lecture that symbol is represented by this sign. This is the representation, symbolic representation of resistance, symbolic representation of resistance. Now also in this lecture we can calculate this calculation of R. We can calculate the value of resistance from VI graph. VI graph means if we plot a graph between this V means potential difference, and the current I flowing through a conductor. From the graph, if we are plotting the graph after experimental verification, I will prove it that there is a straight line, that is OA in this graph as shown in the figure. Along this axis potential difference is represented, along this axis current is represented, and in this graph we have a straight line OA. We have a straight line OA, and we know that graph between V and I, that means graph between potential difference and current, is a straight line OA as shown in figure. Now the slope of this graph, slope of this line we can see, because the graph comes in, because the line comes in the graph. So the line OA, the slope of this line is given by the mathematical trigonometric ratio that is known as tan theta. So we can say, what is theta? Theta is the angle subtended by this line OA with the x-axis or with voltage axis, or we can say potential difference axis. So theta is the angle between OA and OC, and tangent of theta represents the slope of the line. So from the graph we can calculate tan theta from this triangle, that means from triangle OCA or OCA triangle, right angled triangle. We know that this represents OB represents electric current. If OB represents electric current, then CA also represents I, and we know that OC represents already potential difference. So from the graph we can calculate OA, that is tan theta. Therefore we can say slope of the curve OA is equal to tan theta. Instead of tan theta, we know that tan theta is perpendicular upon base. Perpendicular represents here AC, so AC divided by OC. From the figure, AC divided by OC, so AC represents I, so it means I divided by V. Or but we have already discussed above that V upon I is equal to R. Here we have discussed R is equal to V upon I. We can say V upon I is equal to R as already discussed. Therefore we can say slope of the graph we have proved here I by V, but V by I is R, then I by V means reciprocal of R. We can say R, we can transpose here, we can say R is equal to 1 by slope of VI graph. Okay, so we have completed this Ohm's law. Now in the next topic, next lecture, we will discuss its experimental verification. Okay beta, thank you.